Hello, I'm Mohammed Al-Shihri. I'm a PhD candidate at the University of Arkansas at Fayetteville. I would like to welcome you all to the IEEE Computer Society Virtual Conference on Hot Topics in Cybersecurity, second day. This session is on access control in a touchless society. The conference is brought to you by the Distinguished Visitors Program and the Student and Young Professionals Activities Committee. The Student and Young Professionals Activities Committee was developed to support the Computer Society students and young professionals globally through initiatives targeted at advancing their knowledge, development, and careers. The Distinguished Visitors Program was initiated in 1971 by Dr. Stephen Ure and offers top-quality speakers to professional and student chapters. Before we get started, I'd like to get a couple of housekeeping tasks out of the way. You can ask questions in the Q&A panel. Dr. Grajval and Dr. Caldwell and Dr. Subramaniam will answer as many questions as they can following their presentations. The session is being recorded, and the slides and recordings will be made available after the sessions. Our first speaker is Dr. Andrew Grajval. Dr. Grajval holds bachelor's degree in computer science from the Federal University of Ceará, Brazil, a Master of Science in Electrical Engineering and Computer Science from Technological Institute of Aeronautics, Brazil, and PhD degree in Electrical and Computer Engineering from the University of Campinas, Brazil. He also holds a specialist degree in Science Journalism from the Advanced Studies in Journalism Laboratory at the University of Campinas. In 2014, he did postdoctoral stage at the Laboratoire Informatique Université Paris in Paris, France. Since 1999, he has taught at undergraduate and graduate level in Brazilian universities. Dr. Grajval was a user support analyst at the National Center for High Performance Computing and former head of computer science and computer engineering undergraduate courses at the University of São Francisco. Currently, he is a professor at the School of Technology at the University of Campinas and ad hoc consultant in Brazil Ministry of Education and Sao Paulo State Council of Education. Welcome, Dr. Grajval. We are excited to hear your presentation. I would like to pass the mic to you.
Thank you very much, Mohammed. Good evening, everyone. It's a pleasure for me to talk with you tonight. And we will approach some security aspects in IoT and wearable computing. As Mohammed said, my name is André Grajval. I'm IEEE senior member. And as I said before, it's a pleasure to talk to you tonight. For this presentation, we have this agenda. Please don't be scared with the size of the agenda. I promise I will keep in 30 minutes, okay? But we will start with an introduction, and we will talk about IoT in a few words and some economic aspects of IoT. And then we go through some concepts regarding wearables and IoT. So we will talk about wearable components and some definitions according with ITU, International Telecommunication Union, and the architecture of IoT in general, and some communication standards that we should be aware of. After that, we will talk about some vulnerabilities, security, and privacy concerns. So we will talk about OWASP and some top vulnerabilities according with OWASP. some security concerns, some types of attacks, and why it's so hard to implement security measures in IoT devices. In the end, I will talk about some final remarks and show some references. Okay. So let's start with some introduction. I would like you to look at these pictures. So a long time ago, when we would like to access the internet, we should be present in a library or in a laboratory or a university. Not so long time ago, everybody can access the internet with some medium-sized equipment. And now what we have is a picture like this one, this last one. So can you see any difference in those pictures? Okay. The main difference is human, it's getting out the loop. I mean, we have less human dealing with machines now, today. So machine directly talks to machines and may take some decisions independent of the humans. That's the status of the IoT. You know, by 2020, it's the year that we are living now, we have almost 2,000 million cars connected to the internet. Also, we have around 50 billion internet IoT connected things. So these slides try to express the power of IoT today. So this power is not only in equipment, but in money involved in all this market, okay? This graph now, it tries to show how things raised in the last few years, okay? So as we are now, around 2020, we have around 50 billion IoT devices connected in the internet. That's a lot of things connected. And most of the things, unfortunately, they are not so secure. That's something that we will discuss in this presentation. Here, in this slide, I can show you some of the security targets that IoT are facing today. Okay. Then here we have some security risks that we are facing. So some of them are cyber. Let me start from the left side. So it's industry and video cameras and cyber warfare and cars and markets and so on. So we have too many targets that IoT devices can work on. And also these devices or these elements, they can pose some security risks. Okay. Okay, now let's talk about some concepts regarding wearables and Internet of Things. First, the wearables, we can divide them in two main categories. The first one is special purpose devices. So they were developed to satisfy some requirements of applications in specific realms, specifically mobile health. So examples of such category are body-worn cameras or some physiological sensor devices. So these devices are usually plugged in someone to gather some signals, okay? And the other category of wearables are consumer wearables, which are computer with embedded sensors and actuators that can be used as a garment or accessory or some device carried by a person, such as a smartwatch or glasses or something like that. Okay. Also, these wearables are composed by some components, and the first of this set of components, it's a set of sensors. So these sensors are accelerometers, gyroscopes, GPSs, cameras, and so on. So the goal of these sensors are to capture some signs from the environment or from the person itself, himself. Okay. Another component of the wearables are the microprocessor or a microcontroller. This component is responsible for performing some basic calculations or to filter data or to extract some features from the environment. Okay. So a microprocessor is a sort of CPU or a sort of brain that process all the data. Beyond the sensors and microprocessors, we have embedded storage media, which is a component which stores data. Okay. So the storage media, most of the time, are flash type storage media, which store data for later analysis from the microprocessor. And finally, we have the communication interface, which is a way for the device to communicate with other wearables or even computers with more processing power. This communication interface, it can create what we call a personal area network, which is a network of wearable components or a network of some small components, but with some processing power in these components. Okay. Examples of this personal area network could be near field communication or Bluetooth or Wi-Fi or some other small powered network. Okay. And also, beyond all these components, we have the output devices, which tries to interact with the user. So we have output devices that provide vibrations or sounds or visual cues such as light, screens, and so on. Okay? The idea is to notify the user about the device status or some information important for the user. Okay? All right. So let's talk about some more specific definition according to the ITU. ITU is the International Telecommunication Union, which was one of the first organizations that define what is IoT. So for the ITU, an IoT device is something that has anytime connection, with any place connection, and also with anything connection. So anytime connection could be a connection established on the move, outdoors or indoors, or with a personal computer. Okay? Any place connection, it means a connection between PCs, personal computers, or human to human, or human to thing, or even thing to thing. And finally, the anything connection, it's connection with something on the move, outdoors or indoors, at nighttime or daytime. Okay, so according to the ITU, an IoT device is something that have these three vertices, let's call it this way. Okay. All right. when we talk about the architecture of IoT, we have these three levels, okay? So the first two levels, it's what we call machine-to-machine communication. So we have from the bottom to the top, we have the sensing and actuating layer, which is composed by sensors sensitive to phenomena that it measures. I mean, the humidity or the temperature of the time and so on, okay? This sensing and actuating could be passive or active, okay? And also could be analog or digital. So this is the first layer. The second layer is the networking and data communications, which provides connectivity and standard protocols. Also, this layer is tied with power management, and also, most important for us in this talk, security and manageability, okay? These two layers form what we call machine-to-machine communication, and only these two layers, it's not enough to call something an IoT device. So to call it as IoT, we should add the third layer, which is the application layers, okay? So the application layer, this one on the top, is comprised by information format and presentation, data processing, and smart uses of data, especially the smart uses of data, because the IoT itself, the IoT device itself, it doesn't have enough processing power. So most of the time, these IoT devices, it's just sort of man in the middle. So it captures and makes some little processing on data, but it sends data to something bigger, maybe on the cloud, which can process the information with more powerful algorithms, okay? So this is the architecture of IoT. Let's talk about some communication standards, which is fundamental for any IoT devices. So in this table, we have some technologies that we can use for IoT, and some of these communication standards, they work with a small range, like Zigbee on the bottom of the table, okay? So it's around 100 meters. It may seem a little range, but for a personal area network that I mentioned before, it's okay, right? So a small IoT device can interact with a cell phone, which has a 5G or 4G technology, which can have a range of several kilometers and a greater data rate, for instance. So a small IoT device can connect to other device which has a more powerful communication possibility, okay? All right, here in this next slide, I would like to talk about some operating systems for IoT. These are some of the operating system for most of the devices that we have today. As you can see in these memory constraints, the column, we have some operating systems that demands little memory, okay? This is important because most of IoT devices, they don't have great memory capacity. So it's important that the operating system could be small enough to not occupy too much space in the device, okay? Also in the last column, rightmost column here, we have some supported protocols on the operating systems. So it's important for an operating system to support some protocols, especially the ones that are most used from the companies. Okay. All right. Let's change a little the subject and change the focus to some vulnerabilities and security and privacy concerns. Okay, here, in this table, which continues in the next slide, we have some vulnerabilities according to the OWASP. OWASP is an international organization which deals with privacy, especially on web devices, on web in general, but they have a specific section of IoT devices. So these are some vulnerabilities that the IoT devices are subject to, according to OWASP. Of course, we have many vulnerabilities here, but what I would like to stress is some classification of these vulnerabilities. So the first four here are the username enumeration, weak passwords, account lockout, and two-factor authentication, which are related to authentication issues. So this is a category of vulnerability. Okay, we should keep in mind some of these classifications because I'm going to try to propose some possible solutions for these vulnerabilities in following slides. Okay, the next four vulnerabilities here in this table are what we call encryption issues, which are vulnerabilities that we can approach them with some encryption techniques. Okay. Okay. To continue the table, we have some other vulnerabilities here, and the first six here are upgrade and firmware issues, which are some vulnerabilities related to some upgrade or firmware. Okay, and the last two here are what we call control and access issues, which are some vulnerabilities that we can fight them with some control and access controls. Okay. All right. Here in this slide, I would like to highlight some security concerns in IEEE standards. So, as you know, IEEE has a strong work in standards. So these are some standards used at IoT devices. And here we have some main topics related to security. So the topics are authentication, confidentiality, authorization, integrity, and also the last one is freshness protection. So most of the pillars of security, which is authentication, confidentiality, authorization, and integrity, they are supported by the IEEE standards. Okay, the last one is a new one, which is freshness protection, and the only standard that deals with this freshness protection is the ZigBee standard, right? The freshness protection, it's a measure against the replay attack. Okay, the replay attack, it's a kind of attack where an attacker, a man in the middle or something that can hijack the session. He can record a communication session and then reply the entire section or a significant part of it later. Doing this, he can hijack the section and act like the real user. So this is a kind of attack that occurs frequently now, and not all the standards, they deal with it. So the way to deal with replay attack, it's the freshness protection. All right, here we have some type of attacks dealing with some protocol layers. So I divide some of attacks in the physical layers. And also, I divided here in two types of attacks. The DOS attacks, which means denial of service. It's a sort of attack that it avoids the communication of the device. And tampering attacks. Okay, tampering attacks, it's when someone fakes the user. Okay, it puts itself in the place of the user, right? So we have many types of attack here, and some of them are DOS attacks, and other ones are tampering attacks. So more information about these attacks are in this paper in the bottom of the slide. Okay. To continue that table, we have this other one in the transport and application layers. So we have also two types of attack key. DOS attacks are this one, and tampering attacks are that one. Okay. All right. The question now is why it's so hard to implement security measures in IoT devices. So we have to remember that IoT or wearable devices, they have the following constraints. So they have limited energy. Yeah? Most of them most of them depend on batteries, which don't have this long duration. Also, they have low computational power, which means that their processor or even their microcontroller, they don't have too much processing power. And also, they have lower transfer rate. Okay, so the network, it's let's say it's fragile because we don't have enough power to keep the network working all the time, most of the time. Okay. Also, so to implement security measures, we have most of them. They have to implement some cryptographic approaches. So these cryptographic approaches, they need enough computing power. So traditional cryptographic approach may not be applicable because we don't have enough computing power for that. Also, cryptographic algorithms may increase some power consumption. So to validate some carries or to validate some connections, we have to apply some cryptographic algorithms. So we may take some time to processing all this information instead of real processing or processing data from the user. Okay. All right. Some possible solutions to mitigate these attacks are the following. So first, verify firmware at update time. Also, try to use some cryptographic certificates validated by a trusted certification authority, because like this, we can establish the connection and make the connection trustable. And also, another possible solution is what we call physically unclonable functions, which are a sort of digital fingerprint unique to each integrated circuit. So these functions are impressed on the circuit, and we cannot reply it. Okay. Okay. And also other possible solutions are end-to-end security mechanisms, which are mobile application and connected devices must be authenticated separately, and access and authorization control. Okay. Also, equal protection across multiple protocols in the stack. Okay. I'm going to the end of my slides. So I would like to talk about some privacy issues in wearables. So we have to keep in mind that wearables are continue collecting data about the users, and they perform accurate, continuous tracking of speech or non-speech sounds, etc. Okay? And many wearables are designed to not be burdened, which means that sometimes users forget that they are using the wearables. Okay. Okay, and we have three categories of privacy aspects in the wearables. So these categories are context privacy, bystander privacy, and external data sharing privacy. So the context privacy refers to inference about the context the user is in. I mean, the data collected by sensors, like temperature, humidity, and so on. Okay. Also, we have the concept of bystander privacy, which means that it's the problem of collect data from other people. Okay. And also external data sharing privacy, which is data usually forwarded to a cloud service that aggregates, analyzes, and provides feedback about the user. So this external data sharing privacy, it's a problem nowadays. Okay. To overcome these issues, we have some mechanisms to deal with it. For instance, in context privacy, we may deny some data or establish some rules based on geographic location, or in a concept that we call bubble sensing, which means some sensor data, okay, or the data from sensors. All right, and for bystander privacy, some things that we can do to keep bystander privacy as blurring photos or alerting bystander users when data is collected. Okay. For external data sharing privacy, we have anonymization in databases and also aggregating data. Some final remarks for this presentation. The first one is security is a concept that must be considered from the design to the implementation. So when we will design something, independently if it's IoT or not, we should have the security as a main concept since the design until the implementation. So it's something that should be included all the time. Okay. Also, adherence to norms and standards is a requirement for the success of a project. So for a security project, a standard is essential. Okay. Okay. So two last phrases of impact. The first one is the Linus law, which means that given enough eyeballs, all bugs are shallow. This means that if many people works in the design and implementation using security, the chance that we detect some problem, it's bigger. So this is related to the openness. Okay, open projects are good, so we should keep that in mind. Also, we should remember the sixth Kashkov design principle, which means that given the circumstances, the system must be easy to use and should not be stressful to the use or require users to know and comply with a long list of rules. So we should be aware of security, but we also should keep things simple. Okay, simplicity. It's not the antonym of security. Okay, we can have simplicity and security at the same time. And to finish, we have this cartoon, which shows that despite the fact that we keep the security working, we should not forget about the privacy. So sometimes users, they have too much security, but that doesn't mean that they have too much privacy. Okay, so privacy and security are different concepts, and privacy is something that the user should care of. Okay, and here some references if you'd like to. We have some of the papers that I use to create this presentation, but I would like to highlight these two portals in the end, which is the iot.ieee.org, which gathers all the information about IoT in IEEE, and also the IEEE Smart Cities portal, which they have some material about IoT, security, and smart cities. Okay, thank you very much for your attention. Sorry if I get some delay. And here are more information about me if you want. Thank you very much.
Thank you. Thank you, Dr. Andre, for the great presentation. Actually, we have some questions here. I will read it on you and push it to the slides area. The first question that we have here. The wireless protocols listed are at the lowest layer of the stack, physical and link. Is there no security, including replay, fairness, protection at higher layers, like IPI?
Yes, in fact, most of the security are on the higher layers. So in the lower layers, we usually don't have that much security. So most of the security are in the higher layers. Okay, so we have also security in IP and also in the higher layers, especially on application layer.
Okay. The second question that we have, it's about like PUVs are great, but what exactly are you proposing to use them for in IoT?
Yes, the idea is, sorry, it's my cell phone. I'm sorry for that. Yes, what I'm proposing to use them for IoT is to use the PUFs as a key for cryptographic protocols. So as they are unique, they can generate some private keys that we can use on cryptography.
Okay, that's it. No more questions. Thank you, Dr. Andre, for the great presentation. We are grateful having you here. And I would like to thank all audiences. And we are going to take like a moment's break in between our speakers to get things ready. And during that time, you will watch this 1-minute video.
Thank you.
Thank you. Okay. Our second speaker is Dr. Eldon Caldwell. Dr. Caldwell is a full professor and cathedraticus and chair of Industrial Engineering Department of Engineering School at University of Costa Rica, Central America. In addition, he serves as vice chair of IEEE IAS Society Costa Rica, distinguished visitor of IEEE Computer Society, and member of IEOM Society Academy of Fellows, USA, and IEOM Society Global Council, USA. Professor Caldwell earned his PhD in Industrial Engineering major in Lean Operations Engineering and AI at University of Nevada, USA, and Autonomous University of Central America. Moreover, he earned a doctoral in informatics and robotics and automation at the University of Alicante, Spain. Currently, he's doctoral researcher at the Dr. Ed program at University of Costa Rica, receiving the Academic Excellence Award in 2014 and 15. Furthermore, he was awarded Distinguished Academic from the University of Costa Rica. Welcome, Dr. Eldon, and we are grateful having you here.
Thank you. Thank you all. Can you hear me? Everything's okay? Okay. Well, I like to start reviewing the agenda. So we're starting to talk about this situation with COVID-19 outbreak. You know, what is a new world is emerging. Then we can analyze some of changes of enterprise architecture in business. I like to not to put emphasis on the crisis, but with the opportunity that we got in order to technological applications for competitive applications. So we are talk about just a little bit about the main dimensions of technological change in enterprise architecture, especially in that what we call cyber physical systems or CP systems, and then I would like to do some appreciations about how can we start in order to give some tips or to give some advices, especially for emerging countries or emerging economies. So let's start with this new world that it is emerging. I'd like to thank you, and it's my pleasure to share with you in this IEEE conference. But we are not right now living in hard times, you know, and we got to be in our conscience that until 2022, according with the World Health Organization, we're gonna have a lot of problems. So we can see a lot in the world, a lot of people with the illness and a high economic impact. We got losses in only 3 months of the 500 companies with the highest value, according to Forbes, about $400 billion in only 3 months. So we can see that we got a lot of problems in order to employment, or I mean unemployment. So in April, just in the US, we got 14% of unemployment. Actually, it's decreasing, but we can forecast that in the US, we can stabilize the unemployment on 8%. And between 12% and 30% approximately in Latin America. So that's a huge problem for us. And I don't want to talk about the big issues of environmental impacts due to the COVID pandemic, but we can see changes in the environmental issues. For example, air pollution. We got to research with more specifically questions about plastic resurgence and clinical litter in seas and oceans. So, and especially with remote work, what are the environmental impacts about remote working? So I can give a summary about the impact areas. I think we're going to have areas, impacts on social, like health and educations. For example, we're going to see changes in lifestyles and the way that we can access to services and infrastructure. So, and in the area of social and economics, I think we can see resurgence of circular economy. I mean, the sense of well treatment of the wastes and well treatment of all the energy with clean sources. And we can see another area of impacts on environmental and economics, so we can put a lot of attention in the changes of politics and human rights. So, but there's a lot of opportunities. There's a lot of changes in the way we can see the markets. So, for one example, we can see that the brand value of Amazon in 2018 was about $70 billion. Right now, in the 2020, we got Amazon with $221 billion. So, and we can see that behavior of the value of several companies in the world, like Walmart, like Google. So there's a lot of opportunities, but how can we explain that changes? Okay. I mean, we got to review the changes in enterprise architecture, I guess. So, sorry, can you hear me?
Yes, we hear you.
Okay, thank you. Okay, we can review the changes in enterprise architecture. So, I don't want to talk about about the Industry 4.0. I think there is a lot of information in the web. And so, but we can put some attention on what it's the meaning of 4.0. There are several ways to understand the change on the enterprise architecture, but we are changing from not connected systems to interconnected systems. And we are changed from physical objects to cyber-physical objects. That's what we call cyber-physical objects and cyber-physical systems in order to 3 dimensions. Cyber-physical systems is, in a short way, the connection and virtualization of object physics to control it and to use it in both ways, physical and virtual. And we got a lot of devices in order to put on usually in a cloud system, in order to control, in order to put them on a service platform. But I can abstract this change in only 3 dimensions of technology change. You can see other dimensions, but I think this is the 3 main dimensions. Interconnectivity. So we need platforms in order to connect devices, for example, sensors, IoT platforms like the standards of IoT can give us. And the other side, visibility, especially in virtual worlds, and interoperability. Interoperability, I mean, of the platforms that can communicate with the special protocols. So the COVID-19 is a pandemic situation that is accelerating the use of these technologies. Especially I can see a trend in robotics, for example. Robots focus on reducing cost and improving quality. I mean, productivity applications of robotics, to more and more robotics with a sense of social impact, or a more human-robots interaction. And then we can review some of the trends or some of the accelerating issues. For example, online shopping and delivery robots. We are going to see more and more of these applications. Contactless and digital payments. It's a huge area of applications, and we need a lot of cybersecurity developments. IT for remote working and long distance education and health. This is right now a big issue for in all the world, in all our universities. Entertainment, of course, and I think gaming is a big, huge business market in order to see opportunities. Digital twins, 3D printing, so on. The enterprise architecture right now has priorities in order to standards for processes in automated monitoring, industry, and standards for configurability and multi-tenancy, scalability, and so on. But what is changing right now in order to the pre-world of COVID-19 and the post-COVID world? I think we got especially three ways in order to understand the changes. The first one is the IoT platforms, and specifically industrial IoT platforms. So we are going to see a lot of changes in the enterprise architecture in order to put the IoT platforms not only in a secure way, but in a safety way, but in the access. We are going to see more and more improvements in the enterprise architecture. And the second one is the interconnected systems. We're going to see the development of more protocols in order to connect different devices, in order to connect different components of the systems in a simple way and in a simple interfaces for the users. And the CP systems is going to be more and more centered on services, more and more centered on the user and the preferences of the customer. And for example, we can connect everything in a logistics service, for example, for delivery goods. But what is the main idea that we got to consider? I think in part is how these devices, how these platforms are aligned with processes, aligned with the different ways that the work is changed right now. So we're going to see more of this in factories. We're going to have more CP factories, which are factories that can connect machines, can connect shop job shop floor, but can connect people. So we're going to see more interaction with customers, with more interactions with partners in that we call the logistics network. So, which are the most technologies that companies are investing right now? I can mark this just because in the pre-COVID world, we saw a huge trend on, for example, 3D printing, advanced analytics or data analytics, a huge development of artificial intelligence. But I guess that in the post-COVID world, we're going to see more and more of Internet of Things, more and more industrial Internet of Things and other derivations or subjects like Internet of Robotic Things, and more energy applications, especially the clean energy applications. And we're going to see, of course, more digital twins applications, just because in the 4.0 technologies, virtualization is going to be a weapon, a competitive weapon, in order to bring customers' experience with high quality. But in order to control objects in the physical world, for example, we're going to see more patents for digital twins in service areas like health, service areas like banking. And for example, we can see the trend of digital twins patents in companies like General Electric, Siemens, and others like Boeing. But if we can see the investment in different sectors, we're gonna. It's interesting to see the healthcare as an emerging sector with digital twins applications, or aerospace, of course, and wind farm. It's gonna have a huge opportunities of growth. Okay. Let's talk about the changes on these technologies as competitive weapons. I can see that, for example, the first step in order to define a technological innovation, I think it starts with the customer, start with the business model. So we are here on a special space of a competitive increase in order to the value proposal. The value proposal is the several that I call order generators. The order generators are the customer's significant preferences about product or services. So there's a lot of opportunity to contribute to value proposal in order to deliver systems. And IoT, IIoT, and other technologies can be integrated as a one whole system in delivery systems on and service architecture. But what are the trends about the customer preferences? I can see three dimensions, analytic dimensions of this change. The first one is in the economic dimensions. The balance between cost and quality is very important, I know, but not only the how much you can save with a product or service, but the delivery assurance and security about all the digital procedures. And we can see another trends about service. And in the social, I think the values and beliefs of the companies is going to be a high concept in order to the customer, the customer orders. So service and scalability, I think there are other dimensions. And to see an environment dimensions. I guess the next generations gonna have a lot of interest on products and services with clean energy procedures and well manage the pollution and waste in our processes. Okay, so cyber physical systems, IIoT platforms, or interconnected applications must be aligned with the effect of how to make money. So I can see in the environment, in our context, that I would call the sandwich effect. What is the sandwich effect? I can see that the increase of the offer of several digital services, several technologies that we can apply, but the margins, the sales margins, going to be low. It's going to be low and low and low. So the cost can be decreased because of the technology, but other issues like the cost of the labor or something like that could be, especially in this time, an issue for companies in order to deal. So we got to put attention on the profitability. And I can see a trend in order to go from cost paradigm, which mean technologies that are focused on the reduce of cost and operational expenses, to profitability paradigm, which is a paradigm that put the return on investment as a high priority. So the return on investment can be boosted by the rotation, by the asset turnover. I mean, that's because we are going to lean and green or Six Sigma systems in the use of technology from lean and green systems to cyber physical systems. And why cyber physical systems? Just because cyber physical systems can give us less and less cycle times in order to deliver products and services, and cyber physical systems can give us the opportunity in order to reduce assets. Let me give you some examples. For example, let's think about Uber. Uber services are based on digital services, but digital application, but they don't have assets. They don't have, of course, they have assets in the informatic way, but they don't have the transportation assets. So this is a way in order to increase the throughput and reduce the operational expenses in order to boost their profitability. I guess that is the kind of application that we got to put attention in the near future. So the other issue that we got to think is how to balance the value proposal with objectives. that I call nice to have technologies is, I think, we can see a lot of love nice to have technologies applications in countries that are putting the technology like kind of show or kind of only not in a deep way, but only in a cosmetic way. The first thing that we got to think is how to use the cyber physical systems and how to use the interconnected systems in order to punch the value proposal. Several ways are the IoT applications, but in order to give more and more experience for customers, but in a functional way, in a more simplest way. Other issue that we can have is the robotics and safety systems to the reduction of variability, the reduction of defects, and also the reduction of labor costs, and so on and so on. I think here the big issue is how to align the enterprise architecture with the business model. That is a big issue, and the first that we can use. Okay, I'd like to finish this presentation in order to give some tips about how to start. Especially, this is a message for emerging countries, emerging economies. I think we got to align the industry objectives with the university analytics or the research center objectives, and we got to more and more alliances, collaborative work, collaborative networks, and how to put the objectives in one punch way about competitiveness of the sectors. For example, we can have research about how to give to the robotics and cyber physical systems more sense of lean and more sense of Six Sigma quality assurance systems. I think cyber physical systems and lean manufacturing systems are quite separate in our companies, live like two systems, fragmented systems. So the first step is how to use the technology in order to put them on one direction, one way in order to give more service to the customers and to more services to processes. And the last idea that I had to put here is how to increase the innovative thinking as a key factor in engineering education for next generations. I think this is a big issue for the education sector, especially the universities. And I think one of the answers is to have more networking experience like this with IEEE societies in order to put the professional development to service and to serve to the innovative thinking educational proposals. So, okay, this is, I guess, the finished message of my presentation. So I hope this could be valuable for you. And okay, I can hear for your questions.
Thank you, Dr. Eldon, for the amazing presentation. We've got question here, like I'll push it to the slide area, and the person asking about like giving like comments and opinion on like multi-tenancy implies sharing resources. Experience seems to show that any resource sharing can be exploited by attacks like meltdown attacks and other attacks. Like any opinion about that?
Yes, thank you. I missed that we got 3 priorities in order to develop more and more trust of the business systems and the experience of the customers in the systems. These are the cybersecurity standards, cybersecurity applications in order to get more trust in the systems. The alignment of processes, the flow of the processes must be aligned with the technology. And we got some quality of software quality practices in some of these processes. In order to be controlled, we can minimize some of this kind of attacks in order to align the processes. And the other one is the assistance and systems. I mean, assisted robotic systems, artificial intelligence systems, in order to give more predictive straightness to the systems. I guess we got to emphasize on these matters, these issues.
Thank you, Dr. Eldon. Someone asked in here about like definition for digital twins.
Yes, digital twins are the emulation and simulation of physical objects, like you and me, like this computer, like a robot, in order to have it in an avatar way, and in order to have it in a controlled way in a virtual world. That is a digital twin. So we can see right now digital twins about machines, about robotics arms, for example, in factories, but we're going to see more digital twins about other objects in the physical world, like you and me, like human organs, or like inclusive genomic objects, genomic microorganisms.
Okay. No more question. Thank you so much for the very great presentation you gave us today. And now we will jump to the third speaker. We will not go to like a break because we are like to save as much time as we can. Our third speaker is Dr. Subramaniam. And Dr. Sobra has been a consultant professor at Stanford University. He's also engaged in management strategy and technology consulting for startups, international corporations, and investment firms, venture capital, and private equity. And he has served in various roles, including founder, executive chairman, and CEO, CTO, and CSO. His current interests include blockchain technologies, cybersecurity, IoT, big data, AI, machine learning, and financial technology. He's been instrumental in cross-national initiatives in the areas of security, wireless networking, energy, and healthcare and bioinformatics. Dr. Subramaniam is a strategic advisor for the Cybersecurity Research Center and the Dean at National Technology University, Singapore. He's also been a faculty collaborator at University of California, Berkeley, and the Berkeley Wireless Research Center. He has earlier been a fellow at Princeton University, Bell Labs, and held visiting professor advisory roles at ASI and NTU. Welcome, Dr. Sobra, and we are grateful having you here today.
Thank you very much for that gracious introduction, and greetings to each of you wherever in the world you might happen to be. And thank you also for choosing to spend some time with us. I'm looking forward to a fun discussion. As advertised, the topic of my talk today relates to trust over IP and decentralized or self-sovereign identities. And I believe that in the long run, these concepts will have a significant impact in multiple verticals. And I'll also try and show later how this relates to access control in a touchless society, which is the subject of this particular set of talks. There's a sense of excitement and buzz associated with some of these topics, and the goal of this talk is to introduce some of the concepts, applications, and activities so as to whet your appetite a bit. A second goal that I have is to reach out to those in the audience who are excited about collaborative entrepreneurial projects on emerging technology applications. And so with that in mind, I will highlight a COVID area initiative a little later that I would love for some of you to consider joining. But if you're in a rush and need to go, you can think of decentralized identities as helping to transform your physical wallet into a mobile electronic wallet of the future. So instead of carrying around physical credentials like your driver's license, work ID, medical card, etc., you carry them around in a digital form and something that has cryptographic superpowers. So I guess these slides seem to be advancing by themselves. So before proceeding, I just want to, oops.
Dr. Subramanian, you're back on.
Okay, all right. Okay, thanks. So I don't know what happened there, but welcome back. So before proceeding, I just wanted to acknowledge my colleagues and collaborators worldwide. And, oops, seems to be. And I've drawn from discussions on this topic at various forums like the recently formed Trust Over IP Foundation, in which I'm an early participant, and a bunch of others, and I'll sort of hark back to these later in the talk. So just to introduce myself briefly, and Mohammed has done an excellent job at this, but I wanted to shape this a bit. My experience essentially spans industry, R&D, startups, and academia. And the things that I'm involved in at the moment essentially leverage emerging technologies such as AI, ML, self-sovereign identities, data privacy and security in the context of enterprise digital transformation in sectors such as fintech, IoT, and healthcare. And I'd like to use this opportunity to invite you to start a conversation on any of these topics. And my contact information is given here on the slide, and you're welcome to reach out as needed. I'd also like to take this opportunity to, let's see. To be some synchronization problem in these slides. I also wanted to take this opportunity to personally invite you to join an initiative in the COVID era. We're building out a global virtual collaboratory with deep connections to the Silicon Valley ecosystem. And it's essentially a distributed venture studio. The goal is to foster innovation and technology entrepreneurship and to co-create businesses that leverage emerging technologies. So towards this end, we're assembling a worldwide pool of resources, including students and technologists, business partners, as well as product and service providers, and of course, enterprises and consumers with needs and pain points. I've volunteered to mentor a select group of people in this context, and if you're interested, please email me at psubra@ieee.org. So with that done, let me briefly outline the agenda for the rest of the talk. I'll begin by reviewing some of the background and motivation for self-sovereign identity, abbreviated SSI, or synonymously sometimes referred to as decentralized digital identity. So we'll take a look at why it is needed, why it's useful, and why it might be interesting. I'll then try to peel a few of the top layers off, look at what's involved in SSI, how it works, and look at some of the key building blocks of self-sovereign identity. I'll walk through the outline of a demo of how identity might work in a contactless society and how SSI plays into that. Touch briefly on some of the potential applications, opportunities, and challenges in this context. If time permits, I'll point you to some of the ongoing activities in these standards, research, and corporate arenas. And then finally summarize and get back to the question of how you can get involved today. So in the context of this talk, identity relates to the questions, who are you? And how do you prove who you are? So the question of who am I is also intriguing, but it belongs in a philosophy class and is outside the scope of my talk today. So identity is, seems to be skipping us. I don't know why this, okay.
Sir, there may have been a timer on it. That may be what's causing it.
Sorry, there might have been what? A timer?
There may have been a timer on the original PowerPoint. That may be what's causing it.
All right, so let me try to push this back on. Oops, seems to be. Anyway, I'll pretend the earlier slide isn't there. So, that slide is not showing up for some reason. All right, so then the slide
There's a timer on that slide. That's what's causing it to move forward.
Okay, so this slide essentially talks about the fact that the notion of identity and having to prove it is central to accessing both traditional and digital services. So for instance, if you want to vote, access financial services, education, healthcare services, social benefits, etc., or participate in the digital world and do e-commerce online or participate in social networks, you need to have an identity and be able to prove that identity. Now, when you access traditional services, identity is normally proved by us via credentials of some sort. These are typically physical pieces of paper or plastic. So examples of these credentials are things like, things that you carry around in your wallet, your driver's license, social security card, health card, etc. But they can also be things like your registration title from DMV, or your university degrees or credits, and things of that ilk. So what makes this work and the way this works in practice is shown here as what is referred to as the credential trust triangle. So there's the three primary roles that recur whenever we use credentials. These are the roles of the issuer, the holder, and the verifier. So the issuer issues credentials, and every credential has an issuer. Most are organizations such as governments, corporations that issue employment IDs, etc. However, individuals can also be issuers. Holders are people like you and me, but this can be anybody again. Holders request credentials from the issuers and then hold them in their wallets or filing cabinets and present them when requested by verifiers and when you agree to present them or share that information. So although we most commonly think of individuals as holders, holders can also be organizations or even things such as the registration for a car. Thirdly, verifiers can be anyone seeking to trust some assurance of some kind about the holder of a credential. So verifiers request a credential they need and then follow their own policy to verify the authenticity and validity of the credential. For example, when you go through the airport and check in, a TSA agent at the airport will look for specific features of a passport or driver's license to see if it's valid, and then check to see that it's not expired. So that's how that works. So while the other part of this, which is highlighted in the bottom part of this picture here, is something that is referred to as the governance trust triangle. So while some credentials have only a single issuer, others can be issued by many issuers. For example, passports are issued by hundreds of countries, and credit cards are issued by tens of thousands of banks and credit unions. So for any credential that's widely used by many holders and honored by many verifiers, there is a second trust triangle, that is this governance trust triangle, that is used to increase trust and reduce risk in the system, particularly for verifiers. And a governance authority can represent any set of issuers who want to standardize the business, legal, and technical policies for issuing, holding, and verifying a set of credentials. So it can be a government, it can be consortia of different forms, cooperatives, but anybody who wants to publish a governance framework that documents the rules by which the members of the trust committee, of the trust community agree to abide. So here is an example of what might happen in the financial services industry. So the governance authority is MasterCard for the MasterCard network, and it's an authority that establishes the rules of the road for the MasterCard network. You have about 25,000 banks that serve as issuers. You have about 1 billion people that hold cards, and you have about 50 million people who are merchants who use these credentials and serve as verifiers. And there's technology that helps both in a physical sense and an electronic sense to try and minimize fraud and capture other characteristics of the system. So in the case of government, obviously there are different government agencies that touch different parts of our lives. There are foundational issuances, things like issuing birth certificates, death certificates, legal entity registrations, etc., and hundreds of others that are grounded in different subparts of the government that deal with health and driver's license and education and so on and so forth. So a large part of the economy, obviously, is underpinned by the government, and you have a governance trust triangle that's sort of related to how the government regulates these entities. So that's how things work in the real world using credentials. But if we try to translate this to identity in the digital world, what we would love to have is mechanisms that are analogous to this to issue and validate credentials and to share data. Now, this notion of digital identity and trust has proven to be a very hard problem to solve. And it's been kicked around by the community for over 30 years. And one of the problems that relates to why this is hard is that the internet was initially built for machines to communicate with each other without an identity or security or trust layer initially built in. And this was something that was articulated by Kim Cameron around 2005 when he was an identity architect at Microsoft. And part of the reason for this, again, is that the IP address, which is easily spoofed, as are MAC addresses, etc., tell you nothing about the person, organization, or thing that's sitting behind that IP address and is actually responsible for that communication. And this has led to a lot of fraud, and I'm personally aware of this myself. Let me skip over this slide in detail, but let me just comment that one of the key ways to address this identity problem has led to the establishment of a new kind of identifier in the internet system. These are called decentralized identifiers, which are a new type of globally unique identifier, similar to URLs, which are uniform resource locators. So decentralized identifiers, or DIDs, are uniform resource names, and they're essentially designed to enable individuals and organizations to generate our own identifiers using systems that we trust, and to prove control of these identifiers, which is to say, authenticate them cryptographically without an intermediary. And if time permits, I will come back to this point. So the best way to understand SSI, or self-sovereign identities, is in 3 steps, as Drummond Reed from the Sovereign Foundation likes to say, and to look at the evolution of digital identity. In the first generation of digital identity, which is where we started, you establish an identity by registering an account, typically a username and password, with a website or service or application, which is the org in this picture. So pretty soon, you have tens, if not hundreds of accounts, and a nightmare of passwords and password constraints and privacy rules to keep track of. And there are associated standards like SSL, etc., that were developed in this context, but I'll not focus on this here. The point is that the real you, which is in this dotted circle, doesn't really exist without the benevolence of this organization. So the organization can cancel your account at any time. They can share your data even if you delete your account. And obviously there are lots of data breaches and hacks that occur in this kind of a context. The second generation of identity on the internet, which tried to address some of these drawbacks with multiple accounts and permissions and policies and passwords and so on, is called the federated or third-party identity system. So the basic idea is fairly simple. You insert a service provider called an identity provider in the middle, and examples of this are fairly widespread now, both in the enterprise world, where you use something called single sign-on to interact with a bunch of different applications or service providers. And it's also quite prevalent in the consumer world, where you'll see things like sign on with Google or Facebook or Amazon and LinkedIn and so on and so forth. And while there have been several generations of standards that have been developed in this context, and there has been a fairly widespread following, the basic problems still exist to a large extent. And some of these independent or third-party providers become big honeypots for data breaches and cybercrime. And they're not in a position to help users securely share some of their most valuable personal information because of regulations. And if you happen to leave Facebook or Twitter, etc., all of those accounts are lost and your connectivity is all broken. So there's still a number of problems that exist in the identity space. And the decentralized identity model is essentially a addressed at solving some of these problems. So the most important difference in this model is that it is no longer account-based, and instead it returns to the idea of a direct relationship or connection between you and another party, only that the two of you are now peers. So there's you might communicate through agents, and your peer, and this connection lasts as long as the two of you want it to last. So this is, in a way, how the internet itself works. And since the introduction of this, since around 2015, it has accelerated quite rapidly, assimilating new developments in cryptography and decentralized systems, and spawning new decentralized identity standards such as verifiable credentials and decentralized identifiers that I briefly mentioned. So the key idea in some of this is to use public key cryptography and public-private key pairs, but to use in the initial generations a distributed ledger to share the public keys of the participants. So the idea is that if you have a digital credential, a peer would issue you a credential, and this could be anything that you are interested in looking at, and you can then verify this credential, and this is done by cryptographic techniques and what are known as zero-knowledge proofs, and we can get back to that if people are interested. And essentially, that allows you to communicate with the peer, all of these other activities being in the background. And I'll come back to some of the labeled blocks here later, but the point that I wanted to highlight using this slide is that there is the infrastructure distributed ledger in the background that stores public key and related information. There is information related to the decentralized IDs or DIDs that is stored here, and that is a subject of activity in the W3 Foundation. Distributed key management systems are integral to this technology, and that's being worked on in some other standards foundations. And I'll sort of maybe refer to some of these at the tail end of the talk. So this slide tries to capture some of the key building blocks in the SSI ecosystem, and also correlates on the right side of this picture to the technology stack in the trust over IP context. So I'll try and walk through some of the key building blocks here. The first are verifiable credentials that are analogous to your driver's license, and any other thing that you might want to exchange and store with people and that are issued by organizations. And that works at what is referred to as layer 3 of the trust over IP stack. The second key component, which we refer to in abstraction, are the issuers, holders, and verifiers that participate in the ecosystem. The third ingredient in this are digital wallets, which are essentially the equivalent of physical wallets for holding verifiable credentials on any modern computing device, such as smartphones or tablets or laptops and so on. And digital agents are the apps or software modules that enable us to use our digital wallets to obtain and present digital credentials, manage connections, and securely communicate and exchange verifiable credentials with other digital agents. So the digital agents are normally on that second layer from the bottom in the technology stack. And finally, decentralized identifiers, as I mentioned, are a new type of digital address that is both generalized and verified. using modern cryptography, generated and verified using modern cryptography, so that DIDs do not require any kind of central registration authority. And finally, the lowest level, blockchains are essentially globally distributed, cryptographically protected databases that can serve as a source of truth for DIDs and public keys without being subject to single points of failure or attack. And finally, governance frameworks are the set of business, legal, and technical rules for how this SSI infrastructure will be used. And they're published by particular government authorities, governance authorities that are trusted by members of a particular trust community. So as a quick example, which I'll sketch because of lack of time, is essentially a combination of a BC initiative called Safe Sentry BC and a worldwide collaborative that was started in the context of SSI in the COVID era. And you can look at that at covidcredentials.com. So basically, this is a conceptual model for tools that might help us explore ways to help citizens and the economy as we transition from our current state to the new normal. And the goal is, as citizens move around, to help them be as safe as possible. And this includes places of work and other ways to essentially both look at identity as well as data sharing of different types. And so in many places, this will involve knowing more about other people with whom we're interacting, particularly service providers that are entering into controlled access facilities. And these might be places like enterprises, hospital zones, and in the initial case, even people zones. So again, the participants in this kind of an ecosystem are issuers, holders, and verifiers. The issuers in this context are employers of essential services. The holders are essential service providers themselves, and the verifiers are facilities that have controlled access points. And this can be implemented by using touchless, or near field kinds of wireless devices, whether it's your watches, phones, or other kinds of devices. And again, while I don't have time to go through the entire demo and scenario, there are different roles that are played by each of those entities. And for example, here are 3 steps, which says, first, you need to get a digital wallet. You then need to get a government-approved, government-issued, verified person credential, and then create safe entry points. So you'd get a digital wallet. If you're a provider, you'd get yourself a credential from the appropriate employer and or government agencies. And then the safe entry points are things that would be created by the person who owns and operates facilities of different types. And that collection of components would then allow you to do touchless access control. So I'll switch gears now and touch briefly upon the broader applications of the notion of self-sovereign identities. And the whole idea is that since identity itself is central to consumer and enterprise transactions of different types, and SSI is essentially a basis for next generation identity and trust over IP, there's no doubt that there will eventually be widespread adoption of these concepts across multiple verticals. So I've listed some of the sectors here, and these include government, and the pioneers here include the Canadian government, especially the province of British Columbia and Alberta and the like, some of the Baltic states like Estonia, and this is sort of spreading in different parts of the world. Of course, there are lots of applications in finance. Credit unions have rolled out SSI in the form of a project called CU Ledger that uses Sovereign as a public blockchain. MasterCard is a founding member of the Trust over IP Foundation, and there are several other fintech applications. In healthcare, there have been a number of efforts in different segments, including portable healthcare and pharma trials. And in the enterprise, SSI will form the basis for, again, supporting the next generation of identity, as well as data protection and privacy components. And there's a lot of applicability in multiple verticals, including cybersecurity, IoT, and the like. So one way to understand the possible differences in various architectures is by looking at what is driving the demand for them. And we can classify this into three broad categories: the market for business efficiency and customer experience that is focused on cost savings, security, and convenience, and primarily disrupt existing identity and access management systems. The second relates to the notion of resistance to the surveillance economy and talks about ad-based businesses and things of that ilk. And demand in this segment is primarily driven by a mix of ideology, privacy advocates, for example, and consumer sentiment and strategic positioning. So EU and GDPR-related countries are leading this movement because it puts them on a more level playing field with the internet giants, particularly as exponential technology changes continue to disrupt the old world, so to speak. The self-sovereign movement is then also driven by people who want to sort of take back control over their lives. And SSI, in this sense, aims to do for decentralized identity what Bitcoin aims to achieve for decentralized money. So while there are lots of opportunities, there are also some challenges that remain. And essentially, this is what will trigger ongoing R&D, or at least push that. And I've listed a bunch of challenges here in no particular order. The first relates obviously to the ease of use and having easy to understand processes. And so at the end of the day, the idea is that grandma should be able to use SSI in applications without having to know all about cryptography. The second relates to the development of the SSI ecosystem itself. And while some benefits can be realized by individual companies or communities in isolation, the network effects is what is going to really kick in the long run. And this will require multiple industries, governments, and other ecosystems to start accepting credentials from one another, each other. And this in turn will require the infrastructure to reach internet scale interoperability between the various SSI components. These include things like digital credentials, wallets, vendors, fiat and cryptocurrency, etc. And while this is all happening, it's going to take some time for the network effects to build up. A technical issue that needs to be addressed is that of decentralized key management. And key management had been the Achilles heel in the adoption of cryptography in traditional public key cryptography infrastructure. And decentralized key management sort of just is an aspect of that. But on the plus side, it is being accelerated by the growth of cryptocurrencies and SSI and interest in these technologies. Another sort of unrelated aspect that needs to be addressed at some point is the need to have offline access. So while all of these is all well and good when you're connected to the internet or some kind of a communication system, sometimes you need to prove identity without having internet access or a digital device, and a graceful degradation has to be factored in. So people are looking at this, but it's not a solved problem. And finally, of course, innovative business models always help to catalyze adoption. So I'm going to skip the details of the slide. The point was just to highlight the fact that you have applications in e-commerce, which is going from about 3.5 trillion to about a $5 trillion industry, and each of those dollars involves a digital transaction and need to access credentials and identities. So obviously there's a lot of overhead that can be wrung out from that $5 trillion ecosystem. So for those of you who are interested in getting hands-on code and experimenting with applications, Hyperledger has 3 open source projects that are most relevant. This might be a little blurry on the slide, but Hyperledger Aries is essentially the key place where the layer 3 code and the layer 2 code is stored. Hyperledger Indy was an earlier version of this, and Hyperledger Ursa, which you don't really need to know about, it houses the crypto library that is used by a number of projects. So this is just a mention of some of the organizations where activities related to SSI and the ecosystem are ongoing. Trust over IP Foundation was recently launched under the umbrella of the Linux Foundation, and is the looks at pretty much all of the activities that might be related to trust over IP and SSI. And this was preceded and still ongoing. Individual standards related to verifiable credentials are being addressed at the World Wide Web Consortium, which is W3C, and which is also looking at, has standardized DIDs or decentralized identifiers, and some of the other work on key management, et cetera, is going on in different forums. This was an attempt to sort of zoom back the lens and look at the evolution of novel technologies. I'll not go into this in any depth, but the point is that you go through a sort of a transition from having exciting technology to this being used in isolated applications and inside companies, to then moving to a place where sectors are threatened or transformed, such as happened with retail and finance in the internet and the mobile domains, to then going and forming new behaviors and new companies. So if you look at the evolution of the World Wide Web and mobile technologies, this was what happened when you had search with Google and social networks with Facebook and Uber and Airbnb and so on. So we're still at a very early stage of this with SSI, but it behooves us to keep an eye out for what's going on. So let me conclude by summarizing the 2 main points I'd like to leave you with. First, decentralized or self-sovereign identities essentially allow you to migrate traditional identity systems based on physical credentials and associated workflows to the digital world. And so they provide a basis for the next generation or the 3rd generation of identity. They improve trust, privacy, and security, and will have applications and impact in multiple sectors. Second, I would encourage you to participate in our global virtual collaboratory. There's a lot of excitement about it. And if you're interested in working on projects relating to emerging technologies beyond SSI, things like AI, ML, and looking at applications in multiple sectors, please do reach out to me. So thank you again very much for your attention. I urge you to get involved today, now, and look forward to talking to some of you. And if there are any questions lined up, I'd love to get to them. And thanks again.
Dr. Sobra, thank you so much. Great presentation. We've got like a couple of questions here. The first one asking about he said do you want to mention that this topic will be discussed at IIW next week?
Yes, certainly. Thank you for that. So, as I had mentioned in my early slide, one of the key fora where many of these concepts are very widely discussed, in fact, many of them originated out of the Internet Identity Workshop. And that's going on, that happens twice a year, usually at the Computer History Museum, but the last two have been virtual, as is the one next week. So if any of you are interested in this, I'd strongly encourage you to participate in that. So thank you very much for that question and that ad. So it's a great, it's called an unconference, so please do participate.
Someone asking here, do U.S. government or any other commercial organization participating in SSI?
So the answer is yes. There are, the U.S. government does have, several, I guess, government sub-wings that are interested in this, including, some of the early work was, in fact, sponsored by the Department of Homeland Security, but there are various other departments that are looking at the technology, as are a number of commercial organizations. As I mentioned, there's a whole slew of them that are part of the Trust Over IP Foundation, and MasterCard, et cetera, are some of the founding members. The credit union all throughout the US, but also worldwide, which are, I think, several tens of thousands of credit unions, have started this CU Ledger project, which is essentially leveraging SSI in the context of credit union activities. And as I also indicated, curiously, some of the leading countries have been initially outside the US, although there's a lot of US-raised activity. Canada has been one of the pioneers in this context, as are some of the Baltic countries. But then now there's interest and increasing momentum in various industries and pretty much worldwide at some level. But the network effects will kick in. So as you might have observed that any of the networks, including the internet was created as the ARPANET back in the late 60s, and was basically the province of academicians for about 20 years, 15 to 20 years. And it didn't sort of kick up a notch until about the mid-1980s, when the Mosaic driver, browser was developed, and you had the World Wide Web URLs, and then it sort of really kicked into high gear in the 90s, and that's when most people became more aware of it, unless you were in the research community.
Thank you. The next question, saying that Bitcoin today cannot withstand an attack from a nation state with its computing power. What are the implications of that for SSI?
That is an interesting question. So let me sort of zoom back the lens out a little bit. So certainly, while the initial sort of breakthrough in SSI was based on reliance on blockchains, and these don't have to be any specific kind of blockchain. They can be private or public or what have you, depending on the particular application. people argue that a number of the users of SSI, in fact, a high percentage, like 80, 90%, are very local interactions that don't need reliance on a public blockchain. So that is, a lot of these concepts have applicability, even though you might not share keys on a blockchain. But for some key percentage of the transaction, you do need the blockchain, and that's primarily to exchange information about public keys. So, having said that, to get back to the point that you're trying to raise, is that in the context of Bitcoin, of course, you can have attacks. And what you get by those attacks is that you steal keys and you steal money. Now, in the case of SSI, what you will manage to do is steal or corrupt public keys, but that'll be not as valuable as money, but still there are possibly implications of what you might lose there that, are worth taking a harder look at, right? But the infrastructure and the way, different components interact is a little different, but, no matter what you do, there's always going to be risk in any system we have in the world, and nothing's going to be perfect. So that's what people with an R&D hat are paid to invest their time and effort with. So lots of problems remain, and this is an interesting thing to throw into the mix. So thank you for that question.
The last question that we have here, saying that how long do you estimate it will take for this SSI to become commonplace? What would be the catalyst to move it along more quickly?
Sorry, what would be the catalyst for what?
For to move it along more quickly.
Okay, right. So I see it now on the screen. Yeah. So I think the catalyst is for people to realize the advantages it brings to their particular workflow or business that they're looking at, and then to then try and introduce it into the workflow in a way that becomes sort of transparent, because you don't want people to be concerned about the underlying technology, right? You want the benefits to accrue to them. So essentially this is, as I said, already happening in certain limited contexts. Network effects have some challenges. So, it's not going to be, converting the whole world overnight. If you look at, networks like LinkedIn and so on, it was around for, almost 7, 8, 9 years in a semi-dormant mode where there were interesting initial participants. And then after a certain amount of effort, number of people joined, then the network effects kicked in, and it's a useful kind of network to belong to. And so there are segments that already realize the value, and I think this is just going to increase. I think one of the key things to overcome that'll help move it along more quickly is good user interface and good process design, right? So if I were to detach myself from this, I think the discussion around this has involved terminology and modes of use and things and acronyms that are difficult to comprehend. And while there's a certain, the concepts involved are fairly deep, you don't want the average person to be burdened with all of that. So I think good user interface design and good user experience is the key thing to catalyze adoption.
Thank you so much. We've got one more question here, and
Sure.
it will be the last one because of the time. Saying that in case of SSI, the adversary might subvert or steal identity. I pushed the question to the slide there. Yeah.
Yes. So, yes, I mean, the adversary at the end of the day is interested in stealing your identity and then stealing whatever else he or she or it might consider valuable by doing that. So yes, that is correct. The idea is to steal identity.
Thank you so much.
If the adversary is successful, you do that. And the idea is to, just increase the difficulty for the adversary. So that's what SSI is trying to do.
Thank you so much for the great presentation and valuable information we got from here. And at the end, we would like to thank our wonderful speakers and the audience for joining us at this first ever Distinguished Visitors Program and Student and Young Professionals Activities Committees sponsored by Virtual Conference. We hope you have enjoyed it. We are planning to have another one in 2021. About the next conference, as part of the Distinguished Lecturer webinar series, will be on October 31st, 2020 at 6:30 a.m. Eastern Time. And it's going to be about past, present, and future of computing. The webinar will be co-hosted by Geographic Activities Committees, Region 10 Group. In addition to the Distinguished Lecturer webinar series, we are also offer the Build Your Career webinar series that focuses on business soft skills, such as communication and presentation skills, career transition, and interviewing tips. Our next Build Your Career webinar will be on October 21st at 11 a.m. US Eastern Time. And it will be about writing confident, efficient emails by Elsa Filasco Powell, founder of the MNE Group. Registration is now open, and we will be sending you a link to these future events along with slides and the recording of this webinar. Thank you so much.